I'd like to draw your attention to the link at the bottom of today's agenda. It's a link to our custom functions exercise, but I've added 2 more exercises on the end. So if you've previously copied this exercise, you'll want to make another copy of this for today. So there's some new stuff in here, and I encourage you at this time to click on this link, custom functions exercise, that I dropped at the bottom of today's agenda. Make a copy of this notebook for yourself. You'll see some familiar exercises at the top, but I added 2 more at the bottom. Exercises 6 and 7 are the ones that we'll do at the beginning and end of class today. So you'll see the title of this one is Custom Functions Exercise 2, just to let you know this is like an updated version of this notebook. So I'd love to invite everyone right now to, let's see, this is shared, great. Make a copy of this notebook, and if you've already done this, you'll need to make another copy because I added some stuff to it. So file, save a copy in Drive. And so we will work in your copy of the custom functions exercise. And what I'd like everyone to turn your attention to for the next 10 minutes or so is exercise 6, where I'm asking you to create a calculator function. I'm not sure if we dealt with multiple parameters that much, but this exercise challenges you to define a function that has multiple parameters. So hopefully a good warm-up for you. So the function should be called calculate, and it should take 3 parameters. One is a string operation value, i.e. addition, subtraction, multiplication, or division. And then the second and third parameters should be numbers that we will perform that operation on. Maybe you can call those parameters like A and B or whatever you want. And so we'll want the function to perform the desired operation on the desired numbers. And you'll see some example invocations of this function, like, hey, we want to perform a calculation. The first parameter is the name of the operation we want to perform. And then the second and third parameters are numbers that we'd like to use in that calculation. Before I give you some time to work on this, are there any questions about the goals of this exercise? Let's just take a moment to finish what you're working on. And no worries if you weren't able to finish. If you did finish, could I see another raise of hands? All right, cool. So a good number of you. What we will do is we'll share a solution, and that will be a learning opportunity. And we'll talk about a few concepts, and then we'll get into some new stuff for today. So, all right. I would love a volunteer. If you finished, I would love for you to share your function definition in Slack.
Circumstance is the operation is something that wasn't within those 4
Awesome. So what I hear you talking about is, well, we defined a function using the normal kind of way that we need to do it in Python, but you're focusing a lot on talking about this conditional, depending on what operation value someone passes in, we might want to do something differently accordingly. So here we see a usage of a multi-clause if statement. And remember, there's only one way out of an if statement. So whichever operation value matches, here we're using the double equal sign for equality checking. So like, is the operation equal to addition or subtraction or multiplication or division? If so, then we'll do whatever line is indented. And finally, we see that there's an else clause. If the operation was none of these options, in all other cases, just be like, oops, sorry. Cool, that's it. And so now with this, after we run this cell that has the definition of the function in it, we'll be able to invoke this function. So I'm going to run this cell, make sure the Colab notebook has this function definition in its memory. And then afterwards, we should be able to invoke the all this crazy stuff below. And it should work, and our assertions don't yell at us. And so that gives us confidence that we wrote this function right. If these assertions are weird for you, don't worry about them. But the point here is we're able to invoke this calculate function using these desired ways. Awesome. Did you get a sticker already? All right. So thanks for the volunteer. Here we go. I got a sticker. All right. Cool. So I want to take a pause and see if anyone has questions about this function or anything that we did in the solution of this calculate function. Again, we shared this code in Slack, so you should be able to adapt it from there. What's going on with this stuff right here? There's no space. It doesn't matter. We talked about that briefly the other day, whether it's X plus Y or X space plus space Y, that's all good. Here, one thing that I'd like to point out, and the reason why I had us do this exercise, in addition to practicing custom functions, was you see we're defining a function that has multiple values, multiple parameters, multiple inputs, and the order matters. Whenever we invoke a function, to be safe, we'll pass the parameter inputs in the same order. So that's why you see us passing addition as a string first, and then like the number 2, and then the number 10. So in this case, what would happen if I just want to make this point. What would happen if we did this? Calculate, and then like 2, 10, addition. Will this work? I see some no's.
I think it wouldn't work just because it's the wrong order.
Yeah, it's the wrong order. Exactly right. When we define the function, we define the order that these parameters must be passed in. So this would give us, I don't know. I think what might happen here is the first parameter 2 is not one of these operations. So maybe we'll just see oops. But really this is not even, we're misusing this function a little bit. Now let me ask a follow-up question to anyone. Is it possible for us to make this function work as desired if we leave these values in the same order? Right now they're out of order, but is there a way for us to make this work, even passing these parameters in this order?
Operations in apply.
Yeah, well, yes. If we wanted to make it work here, we'd have to reorder the parameters in the definition. But if we wanted to keep the definition, how could we modify this to make this invocation work? Here, let me scroll up a little bit here so you can hopefully see a little better. Anyone? Could we pass these parameters in the wrong order? We can if we explicitly name, well, which value are we passing in? So right now, these parameters are not being named when we invoke them. We're just relying on the order that we're passing them in. And if we pass them in the right order, it's all good. We don't need to also specify which parameter names we want. But we can pass parameters in any order. And the way that we'll do that is by specifying the name of the parameter when we invoke this. So here we could say x equals 2, comma, y equals 10, comma, operation equals addition. And so optionally, you see us naming the parameters that we pass in. And this makes this valid, and this allows us to do addition on these two values. Thoughts? Questions? Can everyone see this? Sorry, this is in the way. So here we're naming the parameters that we pass in, and now order doesn't matter because we're explicitly saying, oh, use this value for parameter X. Use this value for parameter Y. Use this value for parameter operation. And now we can pass these in any order, but only if we explicitly name the values. Questions, thoughts? All right. So next week, when we get into sorting, for the first time, we will have to name the parameters that we pass in, but more about that next week, when we get into sorting items in a list. I just wanted to give you a preview into some things that we'll be doing next week so that it makes more sense to you next week. And this is a great opportunity for us to practice functions.